Hello students, let us learn how to write chemical or the molecular formula of compounds formed from radicals which have different valencies. Here we are taking the case where the basic radical has valency 1 and the acidic radical has valency either 2 or 3. Let's take the first example, sodium sulfate. Just recalling again, we need to write 3 steps for writing any chemical formula by crisscross method. First step is you need to write the radicals, basic or the acidic radical. Then you write the symbol and valency. Then you interchange valency and finally write the final formula. So let's start. So sodium sulfate, the basic radical present in sodium sulfate is sodium. And the acidic radical present in sodium sulfate is a sulfate. Now in the next step, we write the symbol and valency. Symbol of sodium is Na, and just recalling again, we write the symbol we write the valency without the sign. So we write Na1, and since SO4, again it has two different atoms, SO4 in the subscript, put it in a bracket, and we put 2 in the superscript as 2 is the valency of sulfate. In the next step, we need to interchange valency. For interchanging, we write Na as it is. We write SO4 as it is. And now we need to show the interchange. So this 1 comes down here in the subscript of SO4 and this 2 comes down here in the subscript of Na. So the formula finally becomes Na2SO4. Here N is capital, A is small, 2 is in the subscript, S capital, O capital and 4 in the subscript. This is how we get the final formula for sodium sulfate. Now let's take next example of ammonium carbonate. Now in ammonium carbonate, the basic radical present is ammonium and the acidic radical present in ammonium carbonate is a carbonate. Now the symbol and valency of ammonium is here. Many children generally go wrong in writing the symbol of ammonium. Children, please remember it is NH4 with 4 in the subscript. This is the complete formula of ammonium ion and its valency is 1. So we write put the whole in a bracket to avoid any confusion. Carbonate is a C capital O capital 3 in the subscript. This is the formula of carbonate, CO3. Some children omit this 3 and they start writing this as a valency, which is absolutely incorrect. So CO3 is complete formula of carbonate. Put the whole in a bracket and write 2 on top of it. Now when you need to show the interchange, you write NH4 as it is. Again put this in a bracket because whole of it is one formula. CO3, put this also in a bracket as this is also one formula. Now we need to show the interchange. So this one comes down here in the subscript of carbonate, CO3, and this 2 comes down here in the subscript of ammonium. In the final answer, we need not put a bracket here. So our final formula becomes NH4, both capitals. NH4 is one complete formula. You put it in a bracket. 2 has to come outside the bracket. C capital O capital 3. We need not put a bracket here because it is only a 1 here. 1 means if you don't write anything, it means it's 1. So the formula of ammonium carbonate is NH4 whole twice CO3. Let's take the next example now. Sulphuric acid. So children, sulphuric acid is actually known as hydrogen sulfate. So this is how we will come to the formula of writing sulphuric acid. So the basic radical present in sulphuric acid is hydrogen is the basic radical present. And the acidic radical present here is a sulfate. The symbol of hydrogen is H. Its valency is 1. Sulfate is SO4, S capital O capital 4 in the subscript. Put the whole in a bracket, write 2 on top of it. In the next step, we interchange the valency. When we interchange, we write H as it is. We write SO4 as it is. Put it in a bracket. This 2 comes down here in the subscript of hydrogen. This 1 comes down here in the subscript of SO4. Children, please make sure you put the whole after the bracket, this 1 after the bracket. In the final formula, our answer becomes H2SO4. Again, we need not put a bracket over here because it is only 1. So the formula for sulfuric acid is H2SO4. Let's move to the next formula now, potassium oxide. So the basic radical present in potassium oxide is potassium and the acidic oxide is oxide. sorry, the acidic radical is oxide. Then we need to write the symbol and valency. Symbol of potassium is K, its valency is 1. Oxide is O, its valency is 2. So 2 in the superscript. When we interchange, we write K as it is, we write O as it is, we show the interchange. This 2 comes down here in the subscript of K, and this one comes down here in the subscript of O, and so our final formula becomes K2 in the subscript and O. K2O is the formula for potassium oxide. So this is how we write the formula of potassium oxide. Let's take the next example, sodium phosphate. Now here we have one, sodium is the basic radical in sodium phosphate, and the acidic radical present in sodium phosphate is a phosphate. Now the symbol and valency of sodium. Sodium has a symbol Na, its valency is 1. We write 1 in the superscript. Phosphate is P capital O capital, 4 in the subscript. Put the whole in a bracket. Write 3 in the superscript of PO4. Since the valency of phosphate is 3. So this is the next case that we have taken. Now on interchange, we write Na as it is. We write PO4 as it is. Put again this whole in a bracket. This 3 comes down here in the subscript of Na. And this one comes down here in the subscript of PO4. So the final formula becomes Na3 P capital O capital 4. Na3PO4. So this is how we get the formula for sodium phosphate. Coming to potassium nitride now. So here the basic radical present in potassium nitride is potassium. The acidic radical present here is a nitride. So we write it like this. Symbol of potassium is K, its valency is 1. Nitride is N, its valency is 3. It is a nitrite, children. Do not get confused with nitrite. It is N3 negative. So on interchange, K is written as it is, N is also written as it is. This 3 comes down here in the subscript of K. This one comes down here in the subscript of N. Formula becomes K3 N3 in the subscript. So this is the formula of potassium nitride. K3N is the formula of potassium nitride. Let's take the next case now. Phosphoric acid. Phosphoric acid is also known as hydrogen phosphate. So the basic radical present here in phosphoric acid is hydrogen, and the acidic radical present here is a phosphate. Now the symbol and valency of hydrogen, as we've already done, hydrogen is written as H, its valency is 1. Phosphate is a PO4, P capital O capital, and 4 in the subscript, and we've already done its valency is 3. On interchange, we write H as it is, we write PO4 as it is, put this in a bracket. This 3 comes down here in the subscript of hydrogen. This one comes down here in the subscript of phosphate, PO4. In the final formula, we write it like this, H3PO4. We omit the 1 because if nothing is written, it means it's 1. So the formula of phosphoric acid is H3PO4. Let's take the next case, carbonic acid. Carbonic acid is also known as hydrogen carbonate. Hydrogen carbonate. So the radicals present, basic radical, again here present is the same radical, hydrogen. The acidic radical present here is a carbonate. The symbol of hydrogen is H, its valency is 1. Carbonate is C capital O capital 3 in the subscript, CO3, its valency is 2. And on interchange, we write H as it is, we write CO3 as it is, put the whole in a bracket. This 2 comes down here in the subscript of hydrogen. This one comes down here in the subscript of CO3. In the final formula becomes H2CO3. Now again here, children, please remember, we are not putting this 1, we are omitting this 1. Since 1, if you do not write 1, it means it's 1 only. So H2CO3 is the formula of carbonic acid. And now we try one more, ammonium dichromate. This is the next radical that we are taking. In ammonium dichromate, ammonium is the basic radical, and the acidic radical present here is a dichromate. Children, dichromate is a totally different formula which we're going to do now. The symbol of ammonium is Na, H4 as we've done earlier, N capital, H capital, 4 in the subscript. This is the whole is the symbol of ammonium. Put the whole in a bracket, write 1 on top of it because valency of ammonium is 1. Dichromate is, children, known as chromium. It is Cr2O7. Basically, it has a chromium and an oxide in it. So Cr2O7. This is the formula of dichromate. You put the whole of it in a bracket. Its valency is 2. Write the 2 in the superscript. Now when we need to show the interchange, we write NH4 as it is. Put the whole in a bracket. Cr2O7. Children, please, again repeating, do not get confused. Cr2O7 is the formula of dichromate. So you will write it as it is and put the whole in a bracket. This 2 comes down here in the subscript of ammonium, and this 1 comes down here in the subscript of dichromate. So, and the final formula, when you write, we write NH4 whole twice. NH4, again repeating, is one formula. Then you write Cr2O7. This is known as dichromate. We again do not put anything here because the whole of this radical, if we put a 1, it means it's written only 1 times. And finally, we come to the last question for today, that is sodium phosphide. This is the last question which I'm going to discuss. Basic radical present in sodium phosphide is sodium, and the acidic radical present here is a phosphide. Children, please remember, do not get confuse it with phosphate. It is known as phosphide. Symbol of sodium is Na. Its valency is 1. Symbol of phosphide is P. Its valency is 3. From phosphorus, we get phosphide. On interchanging valency, you write Na as it is, you write P as it is. This 3 comes down here in the subscript of Na, and this 1 comes down here in the subscript of phosphorus P. In the final formula, we get Na3P. This is the formula of sodium phosphate. So I hope you all have understood how to write the formulae of compounds which are formed from valencies where the basic radical has valency 1 and the acidic radicals has valency 2 or 3. Thank you.